Hi, this is Grant from Main Street DBAs. Main Street DBAs is your go-to DBA resource with experts in SQL Server, MySQL, and Oracle, just to name a few. So if you'd like to have a dedicated, incredibly knowledgeable, and friendly DBA on your team, drop us a line at mainstreetdbas.com. Okay, today we're going to be discussing transparent data encryption.
Today we're going to review Transparent Data Encryption, aka TDE. First, let's discuss what TDE is. Transparent Data Encryption is exactly what the name sounds like. It's transparent to the end user encryption of the database. So because it's transparent to the end user, there's no need to change existing applications to use TDE. Remember that TDE is an Enterprise Edition feature, so be aware of the potential licensing costs. Why use TDE? If you need to protect the physical database files from unauthorized access, then TDE is a great fit. Also, it may help your organization comply with industry or government regulations. TDE would protect against unauthorized database access if the physical database files or a database backup were ever stolen. To attach database files or restore a database encrypted with TDE, you need the certificate and the private key and the password used to encrypt these two files. Backup files of databases that have TDE enabled are also encrypted by using the database encryption key. As a result, when you restore these backups, the certificate protecting the database encryption key must be available. This means that in addition to backing up the database, you have to make sure that you maintain backups of the server certificate to prevent data loss. Data loss will result if the certificate is no longer available. For more detailed information, see SQL Server certificates and asymmetric keys. Before enabling TDE, you should carefully plan out your encryption strategy and make sure it's well documented. There are some important things to consider when enabling TDE for a user database. For example, TDE does not provide encryption across communication channels. If you need data encryption at rest and encryption over communication channels, then TDE might not fit all your needs. Also, the data in memory is not encrypted, so if there's a memory dump, unencrypted data will be written to the dump file. Also consider that TempDE will be encrypted if any other database on the instance of SQL Server is encrypted using TDE. This can have performance impact for unencrypted databases on the same instance of SQL Server. Enabling TDE on very large databases can take a long time, as every page has to be read from disk into memory. TDE does not increase the size of the encrypted database. Once TDE is enabled for a user database, immediately create a backup of the certificate, the private key, and save the password used to encrypt these files to your organization's password management platform. Okay, now for the demo. Let's look at the certificates table, and there are no certificates created other than the system ones. Now let's create a master key encrypted by this password, and this is going to be associated with the master database. And this needs to be in place before you create the certificate that you will use for TDE encryption. So now let's create the certificate. And look in the certificates table. There you can see it's been created. Now let's back this up, and this is where proper planning comes into play. For this demonstration, it's just going to the local C drive. But if you're going to be utilizing this in production, dev, QA, you'll want to make sure that the certificate and the private key and the password used to encrypt the private key are securely stored somewhere, and unauthorized access is prevented and accidental deletion is prevented. So let's go ahead and back this up. Now let's create a user database and test out TDE. Let's drop if this exists. Let's create the database. Let's get in the context of the TDE database, and now let's encrypt the database. Or rather, I should say, let's create the database encryption key. Now let's get out of the context of TDE database, and we do this because any active connection will not allow TDE to complete. And remember, all the pages have to be read out from disk into memory to be encrypted. Use master, and then we'll set actual encryption on. Now let's verify that we've created or enabled TDE and associated with a cert for this database. TDE associated with master cert. So there you have it. It's relatively straightforward to enable. So now that we've enabled TDE for the TDE database, let's go ahead and create a record. And we're doing this to showcase how you can drop the database and restore. So let's back up the database. Now let's drop the database. And I'll pause the video while that completes. Okay, as you can see, while the video was paused, I expanded my recording view, and the database was in fact dropped. Let's go and look. It doesn't exist. Let's refresh. And trust me, it did at one time exist, because here's the output of the drop database command. So now let's attempt to restore the database now that it's been dropped. Alright, let's restore the database. And I'll pause while this completes, unless it completes before I can pause. There we go. Now let's refresh. Let's open this up and see if our table still exists. And it does. Okay. Now I'm going to show you how you can restore this TDE encrypted database to an instance where the certificate does not exist. In order to show you that, I need to first drop the TDE database and the certificate used to encrypt it. Let's go ahead and drop the database. Now let's go ahead and get into the master and drop the certificate. Let's make sure the database is actually dropped. There you go. Now let's attempt to restore the database and see what happens. Cannot find server certificate with some thumbprint. This is what's to be expected, right? So how do we go about recreating the certificate that the TDE database is dependent upon? So how do we recreate this certificate? Well, we can use the backup we initially took when we first created the certificate, and the private key, and more importantly, the password that we saved in a proper location to recreate this certificate so we can restore the TDE database. This would also work if you were restoring this to a different server. So let's go ahead and recreate the certificate from the backup we have. That completes successfully. Now let's see what happens when we attempt to restore the database. It completes successfully, and let's verify that we can actually read the data out of the table. We can. This was an extremely simplistic demonstration of how to utilize TDE, how to perform a backup and a restore, and also how to perform a backup of a TDE encrypted database to an instance where the certificate used to encrypt that database does not exist. Enabling TDE in your environment is something that should be well thought out and documented. Again, be sure that you have the database backups, the certificate and private key backups, and the password used to encrypt the private keys stored somewhere safely, and be able to prevent unauthorized use or deletion of all of these items. Thank you for watching this demonstration of TDE.